I don't think the music is too loud either. So, yeah. An element has the following property: shiny, brittle, poor electrical conductivity, high melting point. This element can be classified as a... Alright, well, it's brittle, so I don't think it's a gas. Or halogen, obviously. Transition metals aren't like... They're not brittle, because, like, this is like transition metals. Gold is like gold and silver are good conductors, so I don't think it's a transition metal, because like you use like gold and like silver in like computers and stuff. It's either it's metalloid or alkali metal. So like this is these are metalloids and this is alkali metals. I would think that like brittle doesn't make me think of calcium, so I'm gonna go with alkali metals and not metalloids. Let's see if that's right. It's 18A. C. Damn, I was wrong. Brittle, poor, like, cause like, I mean, I guess something between a metal and a non-metal, such as a metalloid. Yeah. I mean, I guess I could have seen like, yeah, I don't know. I guess I just need to remember that like metalloids have poor like electrical conduction, while alkalis don't. Which of the following Ford processes produces a decrease in entropy? Oh, it's something with like, if it's like a gas, then the moles on like this side would be like, what is it, greater than on this side, right? If it decreases in entropy, doesn't that mean that there's less of it and that it's like going all over the place because there's more room to go? So I think that 2 to 3 would not decrease. I think that I don't think 3 is an answer, but then again I look at this and I see 3 is all of them. So I'm gonna assume that I'm wrong there on that assumption, and I got it backwards. Alright. Gas to liquid. That is a decrease in entropy. So it's definitely 1 and 3 for sure. Which I guess means it has to be D, right? Unless it's 1 and 2. Let me look at this one. Oh, I don't remember the ones for aqueous solutions. We'll go with E. C. Alright. 1 and 2. Yeah, I guess I was right on saying that increasing moles it increases entropy. Oh, damn. I had it right, but I just I thought that it was like backwards, because I thought that yeah, I just got confused on that question. I kind of had it right. I kind of had like the right point of view. I just like, yeah. I had flipped the question in my head, kind of. Which of the following will raise the boiling point of a sample of water? Heat the water, mix gasoline into the water, bring it to a higher altitude, dissolve table sugar into the water. I don't see how bringing it to a higher altitude, obviously A is not the right answer. Bringing it to a higher altitude, I don't think that would do anything. I would think that the only thing that would be mixing gasoline with it. Dissolve table sugar. I mean, let me think. Oh yeah, I have birds in the background, so it's gonna be, they're just gonna scream every now and then. Dissolve table sugar. It's either B or D, or B or E, for sure. I don't really know what a magnetic stirrer is, but I don't see how like anything like that could make it, you know, more like, make it absorb more heat before it boils. I don't think that table sugar would do anything. I feel like gasoline has to be their answer. It has to be the answer. That's what I'm gonna say. 20 is B. E, okay, alright. Why doesn't the addition... Gasoline molecules are non-polar. Oh, okay. Alright. What does it say? Only E involves dissolving a solute into water. Sugar water boils at a higher temp than pure water under identical. Alright. I guess anytime you like dissolve something in it, it would increase it, right? I guess. Elements H and J lie in the same period if the atoms of J are smaller than the atoms of H are smaller than the atoms of J. Compared to the atoms of J, atoms of H are most likely. The same period. I don't even know what that is. Is that like this period is like that's like the shell, right? Kind of. They're smaller, so they have a lesser positive charge. Not really, right? Nah. Exist in a greater number of oxidation states. Let me look at this. The atom of H is smaller, so that's like it's up here, right? Because fluorine's the smallest than over here. So fluorine is like, it has less of a pull, right? But that's not what this is asking. Exist in a lesser number of isotopes. I don't think that that's right, because you can like have like plutonium or whatever, wherever that, I don't even know what I'm talking about, but like you can have like uranium and stuff like that has like a bunch of isotopes and stuff, right? So I feel like that's not, I feel like the number of isotopes doesn't matter. Greater number of oxidation states. Is that makes sense to me? That makes sense to me. I'm gonna go with C. 21C. It's either C or E. D. Alright, well. The question concerns periodic table trends, and in particular atomic radius. As we move from left to right across a period, atomic radius decreases. So within a period, the higher the atomic, smaller the atomic. This question is a bit spiced with the camouflage trap. You might be thinking higher atomic number, and the question answer is just phrases. The higher the atomic number, have a greater positive charge in their nuclei. Wait. What is it saying? How is this? I don't get it. It says keep the blinders off your brain. You know the answer, just remember that there's more than one way of expressing it, and it's phrased as this. And the correct answer is phrased as, you might be thinking higher atomic number. Okay, what do you mean you might? Isn't that what you should be thinking? Not you might be thinking is what you would say if it was like the right answer. I'm just confused on how they worded their whole thing here. I have a greater positive charge in their nuclei. They lie in the atoms of H are smaller than the atoms of J. Okay, so that means that it's like this, right? It means that it's like further along, it has a higher atomic number, right? So within a period, the higher, yeah, obviously, that's right. But then the question is a bit spiced up with the camouflage trap. You might be thinking higher atomic number, and the correct answer is phrased as greater positive. Alright. I don't, cause isn't the charge, I mean, I guess that's right, just because like, there's more protons, but I mean, like, that's not how, at all, what I was thinking. I think that this is going to be a balancing one. The coefficient of O2 is, okay, I guess, plus O2. So, yeah, Al2O3, right? 2, 4, so it's 3 times 3, so it's 3. Yeah, that should be right. I don't see that. If that's wrong, I'm a rage. Yeah, see. To the following some brilliant blue color. It's gotta be something with, yeah, it's this, right? E, yeah. Frickin' blue, guys. Yo, what? Okay. Yeah, okay. Guys, don't make fun of me, guys. That's freaking not cool. Alright, more of this. Part C. Wrong thing. Alright. Nope. Okay. Just get my mouse. Dude, come on, bro. Not freaking cool. There we go. Okay, and you crash. Okay, there it is. Resize. There you go. Let me start with that. Alright. There you go. 25%. Oh yeah, I guess if like anybody cares about the thing, it's just the it's just this. It's just the lo-fi hip hop. Yeah, I'm a normie, I know. 25% of element X exists as 210X. Man, I gotta calm down with this ink flow and stuff. There you go. Maybe more ink flow. Yeah, that's good. $214X equals 0.75. 214, is that the atomic weight? Right? That's the atomic rate. Wait. Do I just need to do 25% of 210 and then add it to 75% of 214? Shouldn't it be like the same thing? Okay, 210. That's what I'm gonna try and do. 210 just divide by 4. Then plus 3 times 214 over 4. 210 divided by 4 is 21 divided by, wait. 105 divided by 2, which is 52.5 plus, then this is, 214, 3, 12, 4, 3 times 6, 642. 642 divided by 4, it could be a huge number. 1, okay, 4, 2, I don't know what I'm doing. Okay, how do I divide by, I guess I take 4 down here and then I do 8. I've not done this in freaking forever. It's at 6, 0, and 2. Okay. 162, guys. That's what it is. I hope to God that's what it is. Okay. 162 plus 53 is 511. 215. I have no idea if this is right. Literally none. Okay, did I do my math wrong? Like, or did I have the right idea? I just did my math wrong. So the mass less than 214 is by. Okay. I guess like you didn't even have to do math. In 50% of element X, the thing had a mass of 210. Oh, did I do 210? Or okay, I might have done. No, I did that right. Okay. 50% of 240. The weighted average would be that. Yeah. Notice we were told okay, exists as 214 more than half the time. So this answer must exceed 212. Since element, I'm gonna pull up Wolfram Alpha. Because I want to see if there's like, if I could just do a weighted average, with, so what is it, 210 plus 214 plus 214 plus 214 divided by 4. Is this gonna give me 213? Okay, alright, well, I guess that's how you saw that one. I'm just gonna put that. Because I don't want to get called out for not knowing my chemistry. It's not cool. 600 milli. Okay, well, here's what we're doing. 0.6 liters. That's. I'm not even gonna read the rest of the problem. It holds 2 moles of O2, 2 O2, 3 moles of 3H2, HE. Huh. Partial pressure. Oh god, partial pressures. Let's get this. I have not done this in freaking forever. Partial pressures. Okay. I think that what I can do, I convert it to liters, right? And then I have to, I'm trying to remember how I do this. I think that I do PV equals, I have no idea if I do PV equals NR. I think that I do PV equals NRT. Actually, why would I do PV equals NRT? Because there's a T, I don't, what? Maybe I can just like forget the T because it's like not even a thing. Okay, well, P equals NR over V. Okay, V equals 0.6. Which is 1.6. Okay, I don't need to get all mathy with it. P equals NR, which is 2 times. God, I don't remember this. R is a constant, right? R is 22.4 over 0.6. I have no idea if this is even remotely right. Not a single clue. It's probably not, honestly, because like this is some really like crazy math. Yeah, I don't think that's right. Dude, I literally remember doing partial pressures and it being like the easiest thing on the freaking planet when I was doing it. So this makes me mad that I can't do this right now, that I forgot how to do it. Holds 2 of that. Okay, I'm gonna add them together. I'm gonna find the molecular weight. So 2 times 32, so 64 plus 3 plus 6 plus, how much is helium? It's like 6, right? 4, something like that. 74. Do I need to do, that's how many of that there are. Man. Yeah, I have no idea. I'm gonna look at it and I'm just gonna see like, that is like the easiest thing. 6 moles, 1/3. Oh my freaking god. Okay, yeah, that's embarrassing. Yeah, that's freaking embarrassing. It's 253. Okay. Well, cause like I literally know like all of this math because I had to do it last year, but I've not even done it in like a year, like at all. I've not looked at like any of it in a year. The only thing that I've looked at is like I did like a little bit of pressure in physics, but that was like different type, and then I did thermal stuff. But like the thermal stuff I can do no problem. It's just like it's the freaking the balancing is also easy. No, I remember how to balance. That was like the funnest part of chemistry. But like all like the really weird like the bonding and stuff, I freaking, dude, I'm like so lost on that. I like, even when I was doing it, bonding was like the only test or like quiz thing that we did that I just had no idea what I was doing. Like I know what like the bonds kind of are, but like if you ask me like any deep questions about it, I'm just like lost. I freaking hope that like this test is just like a whole bunch of this, because like this I can learn, and like 2 weeks. I can like learn all the math and chemistry in 2 weeks and then just forget it and then remember it because I'm taking AP Chem next semester. But like, man, the rest of this is just like kind of crazy. It's added to water and dissociates into component ions. Solubility product. Isn't it products over reactants, or is it reactants over products? I'm pretty sure it's products over reactants. I think that's D. Wait. What am I looking at? Oh no, it's E, right? Wait. Hold up. It's something... Man. Now I'm confused. I think that it's... Yeah, no. It's E, right? Yeah, it's gotta be E. Homie, it has got to be E. Okay, homie. Okay, alright. Let's see. So considering the dissolution of an ionic solid into water, we need to consider the solubility product expression. The solubility product KSP will equal the product of aqueous ion concentrations raised to their coefficients, and that solids are not expressed. Oh, is that a solid? Oh. Okay, so I think that I like had it right, I just didn't remember that rule. Alright, that's fine with me. If I like, if I can like get like the basic knowledge and then just like forget the rules, like the specific rules of each one and just like learn those later, like as I'm doing it, like I'm learning it now, then I think I'm gonna be really good for this test. Cause like, there's no way that I could remember like a lot of the rules, like the really specific stuff that's like, oh, you don't use solids here, oh, you don't use like, you know, if it's less than 4 then you don't count it sort of stuff. Like, and I'm a god at this, like, dude, this freaking 1s2 thing, like, I'm so good at it. Should the following electron atom of magnesium in excited state. Freaking what? Excited state. 12. It's not that. That's normal magnesium. 3p2, 3p1. It's what it... I think that it's gotta be C. Cause you don't... Yeah, it's C, right? D, what the hell? Just as it should be. Okay. It's been pushed up into a higher energy state. Okay. I didn't know that that's how you looked at that, but alright. All of the following when added produce an electrolytic solution except... Oh, I have no idea. Calcium probably not. Definitely not nitrogen. I have a hard time believing that someone adds hydrochloric acid to something. That's not hydrochloric acid, but hydrogen chloride to something. Potassium, you can. I'm gonna go with B. I think it's B. It's A. Alright. Well, the one that I said was literally not. Which ionizes into that. Which ionizes into those. Are all ionic solids, which will break down into multiple ions. No ions produced in the resultant solution. See, like, I don't... How do you know, like, what ions produced? That seems wild to me, to just, like, know that. Cause, like, I don't... There's no... Is there any way to, like... Is there a math way to do it? Is there, like, a knowing way? Or do you just, like, have to know that, like, the activity series and all that? Which I don't. I still don't remember. Probably gonna be screwed on that portion, but whatever. NH4, okay. It's not an acid, right? It can't be an acid. Indicator, hydrate, base, salt. Is it a base? Is it a base? I think that it's a base. It's not a salt. I think it's a base. I don't know what an indicator or a hydrate is, but hydrate... could it be a hydrate? But that's like hydra, that's like water. But like, could could it be though? Alright, it's A, B, or D for sure. Whatever. C. Okay. Man, this is brutal. This is freaking brutal. Holy God. Oh my God. I'm like, dude, this is freaking crazy. It acts as an acid at Bronsted-Lowry. I'm to figure out what that is. I remember hearing it, I just don't remember what it is. What is this? Acid plus base equals conjugate base plus conjugate acid. So why is this not the base and that the acid? What? Why is that backwards? Is that like something that I just like don't remember? Probably, well, obviously it is. A and B are Bronsted-Lowry bases. Accepts, base accepts H. I. That's freaking crazy. Yeah, that's freaking wild. It's just like, it's backwards from like what you'd expect, because this doesn't have, this isn't an acid, this is, well, like, this accepts H, but like, man, what the hell? That's freaking wild. I guess because like, I guess like what I'm looking at is that like, it accepts, okay, alright, here's what I'm saying. Alright, this accepts, this to this accepted H, so therefore that means that this is an acid. This to this donated, so since it donated, like, it lost the hydrogen here, and it gave the hydrogen to that. So even though like this isn't like HCl or like whatever, this like accepted a hydrogen, even like, so therefore it's an acid. Which, I mean, I don't understand at all, but I remember doing that in like normal chemistry, and like dude, like, cause this is so sad because all this stuff I found super easy in chemistry. And I was just like, oh yeah, that makes sense, and then now I'm like struggling. Man, I wish I took this test right after chemistry. That would have been so nice. I can't, like, I had no idea that these tests even existed until like freaking halfway through my junior second semester. I'm just like, oh. And I was like, I literally looked at the chemistry test. I was like, oh, this is like really hard. I don't know what any of these words mean, so I'm just gonna take the physics one. And I took that freaking physics one, dude. That was difficult. That thing was hard. That thing had so much stuff on it. There's like, bro, if you're 10, 18, what is it? But like, dude, if you're like sitting there taking that freaking physics, alright, chill out, guys. Chill out. I think it's S-2. CR plus 3. CR's in the middle, no way. Yeah, no way. Neon, yeah. Bromide -1, no way. No way. Yep. Wait, hold up. No way, right? No. We got that. 7 is A. Yeah, we got that bread. Okay. This is like smooth, right? Amphoteric is smooth. I think it's that. I have no freaking idea. I hope that it like, is it C, B? Okay. What does it say? It's a strong base when expected to, okay, first it must be able to donate and receive H. These species don't even have an H to donate, yeah, okay. It's a strong base when expected to ever act as an acid. Likewise, it's a strong acid. Okay. Yeah, okay. Um, alright. I guess I just needed to know. I just needed to know that this is like a mediocre acid. That this is like, or that it can like be an acid and a base. I was right. I mean, I wasn't right because I didn't think about this, but like I was kind of right because I didn't pick ARE. Um, but I guess I just needed to know that nitrite, or that like hyponitrite or whatever this is called. It's like hydrogen nitrite or something. It's the acid thing. Um, I think it's like nitric acid actually. Um, can is a strong acid, and that this isn't. I would have gotten these mixed up if I had known that that was a definition. I would have picked that this was the that this was a strong acid and that this wasn't, 'cause this is like sulfuric acid, or like what it can become, I guess. If you do H2, it becomes sulfuric acid, which is like a big thing, apparently. An ideal gas has 10 liters, has a volume of 10 liters at 20 Celsius and a pressure of 750. Which of the following expressions is needed to determine the volume of the same amount of gas at STP? Alright, chill out, bro. You're speaking a million words a second. 10 liters. Okay, well, we know it's gotta have 10 times something. Let's see. 760 is STP. Okay. Here's my. Obviously, it's not gonna have a 0 at the top. That's ridiculous. Um, if it has a 0 at the top, I'm a freaking rage. Um, 750, right? Is that what it said? Yeah, 750. I think that if it has less pressure, that means it should have less volume, right? So I'm gonna go with 7. I'm gonna go with that. I'm gonna go with B. It's either B or E, because those are the only ones that make sense across the board. So like, right? Wait. It's either B or D. I mean, it's able to do that. Because like, that would mean that it would have more volume and more. Wait, hold up. I gotta take a chill. I gotta chill right now with this thing right now. I gotta listen for a second with this. Okay. So it has more pressure means less volume, right? Alright. And then less pressure means more volume. Alright. So 10 obviously, but we're going up in pressure, so that means we have to go less in volume. So that means we need like something. God, is E right though? Cause E is like backwards. I think that it's gotta be that, right? Right? I think that it's 9. I think that's B. Fucking, of course. Okay. Alright. Come on. Come on, bro. Like, this is freaking ridiculous. PV over T. Alright. P times V times 1 over, or times whatever over that. I should have stuck with, I mean, I don't know. I don't know what I should have done. I don't know how I could have, man. I'm mad about that one, actually. I'm real mad about that one. That does not make me feel good. Man, that's freaking disappointing. It's point 0.05 atmospheres at 200K, and the pressure is it'll go into a liquid. Go from gas to liquid, which means condensation. Oh man. Is that like the triple point's not at 200? No. Yeah, was it A? Yeah. Normal boiling point at the substance. Boiling is where it goes from liquid to gas. It's like at 200, right? I'd say so. The boiling point is like, that's like the triple point, right? That's the lowest point that it can boil. Oh wait. 1 atmosphere. It's like 300. Okay, it's either B or C. I don't know. Yeah, it's C. Yeah. This 1 atmosphere is where you have to do it. The shape of PCl3. Trigonal. Oh, is it pyramidal? Is it planar? Oh. Trigonal planar is boron. So I'm gonna go with B. Yay! Got it right. Which volume of that is needed to neutralize that? Okay. 100 mil. 0.1 liter of 0.2 m HBr. Okay, zero idea how to solve this. Let me think. Okay, it's 2 to 1. This to this. It's 2 to 1, and does that mean you need 0.2 liters? There's something with that OH being 2 and that H being 1 that makes me think that you need more than that. Okay, I'm gonna go 400. Maybe I got it backwards and it's 25. Okay, here's what I think it actually is. Here's how I think this works out. It's 2 to 1 based off the molarities, alright? Or whatever the M's are. Molality, molarity, same difference. The concentrations. Okay, so the fact that there are 2 OHs there makes me think that not only do you need less because it's 2 to 1, because it's more concentrated, but you need even less because there's 2 OHs and only, yeah, I think that is A. It's either A or B. A. Okay, I just like alpha the hell out of that question. I think that I even had like the right reasoning too. So for 2 moles of HBr, we have 1 mole of that. Yeah, I got that. So we have 0.1. Okay. I don't even think that the liters are important really. You know, outside of finding the answer, it's like dividing by what you normally do without the specific liters. So you divide by 0.2. We need 0.1 of that to neutralize that. See, I don't really follow what their math was, but I think that my math was like pure right. Like my idea was right, and then I could just do that on any problem like that. Cause like their like explanation doesn't really make much sense. Need 0.1 mole of yeah, I got that. But 0.01, like that doesn't make sense. Why 0.01? dude, like, mole per liter. Oh, I see what they did. They multiplied the liters to get the moles. They got 0.02 moles of that, and they need 0.01 moles of that to neutralize that. Man, that's freaking. Why would they do it like that? Yeah, I don't like how they did that. I think that I did it the right way, but without doing all the freaking math. I don't know the aqueous dissociation, any of that stuff. I don't know that. Rip. Please don't crash. That would be epic if you didn't do that. Now could you please? Oh, I need to hit new. No. Die. I don't think it's a strong acid. It's carbon and nitrogen. That can't be that strong. That's 10, right? Man, I have no idea. What is it? I don't even know what the Ka is. That's freaking rough. Yeah, that's a rough question overall. I have no clue. I'm going to go just on base. Obviously, it can't be. Can it? No, it can't, right? How does that make any sense? Dude, what the hell am I looking at? Dude, fuck it, honestly, I'm just gonna hit that. Fucking D. Oh, sweet. The small Ka what is Ka, bro? Okay, can a homie just please help me out with this? Like, what the hell is Ka? Okay, I got that it's that. I know that it's that. Actually, I did know that. I don't, however, know like how you can tell what a small one or a big one is.
Let's look at this acid base a proton. It's going to with the conjugate.
Okay. This is just like backwards, like Bronsted-Lowry thing, right? Yeah, pretty much. This means that it accepted an H, so it's an acid. Yeah. Okay, I got that. What did they even do here? This means statement 3 is false. A small Ka indicates it's a weak acid. Okay, what is a big Ka then? Like, what's the range between those, of those? Would be 500 is a big Ka or something like that? Like, I don't know. It also means that most HCN remains as intact molecules. Okay, I don't know. So statement 2 is false. Okay. Small Ka means that it remains as a molecule. Process of elimination tells us that statement 1 must be true. And it is. Okay. Sure. I looked, I didn't see it, but I did do that. Second largest ionization energy. The largest second ionization energy. What does that mean? Oxygen? No. Wait, hold up. Hold up, bro. Is it chlorine? I don't know what they're getting at with that. Iron. No, it's not iron. Wait, hold up. The most, the larger the ionization. Okay, ionization trends. I know that, I don't remember if it, yeah, it increases from left to right. Okay, that's what I thought. Silicone. No. Silicone is lower than calcium, or, that. Chlorine's bigger. Sodium's bigger. It's gotta be, it's C, right? It's fucking E, what? You're more attracted to strongly. Dude, what? I don't even know, what do you mean largest second ionization energy? What does that mean? Okay, ionization energy is like, it's not like, that's giving an electron, right? If you ionize something, that means you give it an electron. So I do not see at all how this, like, looking at this, right? This is electronegativity, and them are backwards, right? Isn't that the case or something? Dude, that's freaking ridiculous. I don't. That's stupid. Come on. You're really gonna do me like that? Like, the most electronegative is that. I mean, I guess because what they're saying is, like, if you took one, obviously, that's fine. But if you took another, what would be the hardest to take? That second one. And in which case it would be sodium. Because iron is just like, you take two, it's whatever. Chlorine, you take two, it's like, it doesn't want to, but like, it gets easier the second time than it does the first time. Calcium, I don't take one. Alright, take one, and then take two at once, take another one, that's good. Silicone is just like taking, it's just not as strong as sodium. So I mean, I guess sodium makes sense there. I just didn't really think about it like that. I didn't know what the question was really referring to when it said second largest ionization, like second largest. That didn't register with me. Okay, potential difference. Don't know this. I mean, I'm supposed to know for chem, but I don't. Or for physics. I don't know it. Whatever. How could I know that? Come on. V2 is oxidizing redox reaction to get the standard oxidization. Yeah, I got that. It's just plus E to the 1, right? Something like that. E to the whatever. Dude, what? I'm not even like following at all remotely what this is saying. Goes from Fe, so it's, okay, I see how that's negative, because it's just the inverse of it, it's flipped. Okay, then Cl2 plus that. Okay, so that's normal, so didn't you just add them? Okay, that makes sense to me, actually. Yeah, I kind of get that more now. I'm not gonna mark anything, but like, I get that, kind of. Okay. Zinc and hydrochloric acid. Zinc plus HCl. zinc is plus, right? Zinc's plus, right? What is zinc? Zinc oxidation number plus 2, right? Yeah. Plus 2 minus 2. So zinc Cl plus H plus 1. Cl's minus 2, is it minus 1? I think it's minus 1 actually. Yeah, it's minus 1. 2. H plus 1. Okay. It's just H2, right? It's just, whoa, hold up, bro. Hold up. For sure 1. 1's for sure. Zinc bonds with Cl. Unless I'm missing something, zinc bonds with Cl. Whoa, I really want to see what this answer could be, because I get that 1 makes sense to me, obviously. 1 makes sense. I didn't put the 2, but like, I know it's diatomic. Cl doesn't make sense to me being alone, because negative in zinc is positive. So those should go together, right? Like, why wouldn't they? Okay. D. I mean, I got it right, but... Oh, I see what they did. They did like what I did. Like, I got the right answer, but like okay, so HCl is it's an acid, obviously. Well, hydrochloric acid is what it is, but an acid and a solid together would make an aqueous solution. And since if Cl was registered as aqueous at the end, it would have been 1, 2, 3. But since it was gas, it's not. Okay. So, like, once again, like, it was just, like, a weird question that they worded that way. Like, I don't know why they would refer to it as zinc aqueous, when it's, like, also, when it's not just zinc. That makes me think that it was, like, only zinc, but that's not how it is. Equilibrium concentration of SO2 can be, SO2 gas can be, increased by increasing the temp. Could it? I don't think so. If you increase the temp, that means you decrease that. You decrease the rest. Okay. Add a neon gas. No idea if that's true. Any catalyst, that would decrease it, wouldn't it? So make it easier for the reaction to occur. Or make the heat. I don't know. I have no idea. Increasing the concentration of H2O, increasing the concentration of O2. Now, if you increase the concentration of H2O, then you decrease that. If you increase this, then you have to increase its E, right? E, yeah. Yeah, I honestly, like, I'm really impressed that I actually answered that question, like, thoughtfully, because, like, I actually did find that sort of stuff really difficult, or that stuff difficult. Did they give an answer as to why adding neon gas wouldn't make a difference? Catalyst. I was gonna say catalyst. Like, that's kind of. I didn't think that they really. I don't know. I just didn't think it was the answer. Changing concentrations does. Yeah. Okay. Alright, that makes sense. Which of the following is increased by decreasing the volume of the reaction? Hold up. Okay. Which of the following is increased by decreasing the volume of the reaction system? Okay, so if I decrease the volume, that just means that everything goes down. Rate of the reaction. Don't think, would that change? Equilibrium. No, because everything goes down, right? Whoa, hold up. doesn't it have to? Cause like the concept, like it goes down with like respect to like everything else. I think that it's like 2 and 3. Don't quote me on it though. I have no idea if I'm right. Value of Keck. No, right? No. Wait. No. It does. It does. It's D. It's frickin' A, of course. It's the one that I like. It's literally the complete opposite of what I thought. The exact opposite of what I thought. I don't. What is Keck then? What does Keck change? How's Keck changed? Keck. This is what I thought Keck was. Yeah, it's this, and this is the. Is it? What? How? Homie, how? Okay. Yeah, this is what I thought it was. Wait, it's the. Okay, I got that. I mean, I don't have that. How? No, because like, how does that not decrease if these numbers go down? They go down the same, right? They go down by like, I guess literally not, because like, it's a ratio that stays the same. Okay, so I guess 3's not right. Because it's a ratio. Equilibrium concentration of reactions. Decreasing the volume of the system will increase the concentration of the reactants. Because the same number of molecules now exist in a similar space. Holy fuck, that's fucking wild. And this increases the ratio of molecules per volume. How will this affect the reaction rate? It will increase reaction rate by decreasing. Okay. By decreasing the it will by decreasing the volume makes it more likely that molecules will collide. Okay, dude, I just took a big L on that question. Like, holy god. I kind of get it where it's coming from with the, I don't really get the reaction rate thing, but like I kind of do, because it's like, it's a smaller volume, but it's like, cause to me it's not even like it's like smaller pressure is what it's really saying. Like it's still the same stuff, but it's just like in a smaller area. Like it's the same concentration of stuff, just in a smaller area, so therefore it like collides and reacts faster or whatever. The equilibrium concentration obviously decreases because the volume's decreasing. And then Keck is a ratio, which I don't get why it says Keck will only change based on temp. That doesn't make sense to me because Keck isn't based on temp at all. Like, where is temp in this at all? Yeah, I don't. Effect of temperature on Keck. Okay, please tell me how they changing on temperature favors one reaction of the other, therefore a shift in Keck value is caused, as well as a change in participants. Yeah, this is what I said, that it's like, it's like a ratio that the others change, as well. I don't, cause like there's no temperature added there. A new equilibrium will be reached with its own Keck. Oh, okay, I see what it's saying. So it's saying like here, that like, this side of the equation there's like more concentration than this side or whatever, and that part of it is just offloaded as heat, which isn't gonna be NCAC. Okay, I see that. Was that 20? No, that was 19, so that's good. When 3 moles of Fe2 are allowed to completely react with 56, how many moles of iron are produced? Well, time to do math, or time to do, not math, but balancing. Okay, well, that's yikes. That's a real yikes for me. Why is that there? Okay. Fe2O3 plus 3CO 3 2 Fe plus 3CO2. What the hell? Let's just balance this. Fuck it. 6. 9, 12. 6. 6. Alright, well, here we go again, guys. This is gonna be epic. I have no idea how I can balance this. Let me look up a chemical equation. God, I really don't want to use one though, cause then I'll get flamed. Man, come on. Why can't they just be easy, bro? I swear to God, this like doesn't even require like any balancing either. That's like the funniest part, is that this doesn't. Fe2. How much is Fe? 56. 56 times 2 is 112. Times 3 times 16 is that 3 times 16 is 48. 112 plus 48. 0, 6, 1. That times 2 is 0, 12, 2. 220. Okay, we got that money. 220. Hmm. 220 times 3 is 660. Yo. I did that all wrong. Actually. It's 160. Screw you. 160 times 160 times 3, so 60 times 3, 0, 18, 180 plus, so it's 480 grams Fe2O3. Dude, that's freaking crazy. Is it not 2? Like, come on. You really gonna do that to me, bro? Alright, well, let's see. It's definitely not 2. It's gotta be over 2 though. It's either, yeah, something like that. Let me think. I'm just trying to like think about like how that works. It's not offloaded. No, it's not actually. Dude, like, I'm so struggling, even though I should not be. This is freaking wild. I should not be struggling on this. 480 plus 56. What's that? That's 536. 2 times, or well, FE is 56 times equals 56x plus CO2, which is that 12 times 16, 12 plus 16 is 28 plus 16 again. Well, it's 42, I think. 32 plus 16 is 48 plus 48. 56 minus 536 minus 48 equals. Whoa, bro. Gotta take a second, bro. I already remember how to subtract. Okay. 16, 8, 2, 8, 4, 488. Okay, we got that. 488 equals 56x. Okay, well, 488 divided by 56. God, I have no idea. It's, dude, come on. It's gotta be like 6. Then again, it has to be like, dude, this is fucking crazy. Is it E? Is it B? It's B. Okay. Here we go again. Let's freaking, I'm like so out of it right now with this. That's 2 moles of that. It's 1 to 3, right? Sure. You see that CO is limiting. Yeah. Wouldn't I need more? We would need more than 9. No, we wouldn't. We would need 9 moles. This ratio of CO to Fe is 3 to 2. Okay, I see how they did that. I see how they did that, actually. You know, hats off, because that's like actually a really cool way of doing it. I'm still mad as hell though, that like I'm even having to do this. Like, I hate this so much. 0. That is sodium peroxide O2 water react in a flask at 25 according to the equation in the diagram above. If water levels are equal inside and outside the beaker, then the gas pressure inside the beaker is equal to pressure of the oxygen gas collected. Okay. Dude, this is fucking crazy. Bro, like what? What am I even like looking at? Sum of pressure and oxygen gas collected in atmospheric pressure. Sum of vapor pressure of water at 25. Okay. I think that it's C. I have no idea though. That's freaking wild. I don't even follow. I don't even follow. Please, dear dear God. Dude, this, I don't even know what the curve on this test is, but I'm pretty sure it's like -5 and you get like, what is the curve on the 8? Dude, come on, why don't you tell me a straight answer? I know it depends on the freaking particular test, but tell me like the roundabout answer. No, you can't. Freaking no, you can't. That's not true. Idiot. What? Oh my God. 82. What? There's 80 questions on it. What do you mean? You need a raw score of higher than the actual thing. Okay, so 5. Wow. I don't like, this is freaking crazy to me. Pressure exerted is equal to the water vapor pressure of water. To the vapor pressure of water. Dude, no, like I don't even understand what what this is. I don't even follow like what that setup is. Is it like an upside down beaker that's like not even, it's like floating or something? And there's like a glass tube going up into it? Like that doesn't make sense to me. But there's like water in it. Okay. Sum of the pressure of oxygen gas collected in the vapor pressure of water at 25. Okay, I could not follow that at all. Strongest carbon to carbon bond. Oh my God. I guess I just have to draw them. C2H2, C, H, H, C. I guess I drew that wrong. I have no idea. Do they? One goes up here, one goes down here, right? So you get double bonds here. That's how that works. What's the next one? C4H10. Dude, come on. One, two, three, 4, 5, 6, 7, 8. Then like, dude, what? 9, 10. Yeah, there's no way that one's it. C3H8. Let's see if this is could be it. C, C, C. I have no idea if that's how they bond. Two, 3, 4, 5, 6, 7, 8. I think that it's A. Honestly, I don't think that it could be B. I don't think it could be C. I think that's got to be A. A. I mean, that makes, yeah. I guess I kind of drew them out, right? Not really though, but I mean, like, you could legit, like, honestly, kind of tell, I guess, because I didn't even look at the problem first, really. I just, like, assumed, like, when you have two, like, I guess, because you have two all the way throughout here, so the only one that you have to test is the lowest one, because, like, that makes the most sense. Like, this, obviously, because there's not going to be as many electrons, it's just going to be spent on pointless hydrogens. You can have the most electrons not being spent. And then, like, you have to check, like, D and E. You don't even have to check, like, honestly, like, you don't have to check D, really. You can just, like, tell that it doesn't have a triple bond, but I'm not that smart. If the experiment was carried out in a closed system at constant temperature, then which of the following, during which time interval would the reaction most likely achieve equilibrium? That's when they don't change anymore, right? It's 20, right? Because that's when they don't change. That's not when they're equal, that's when they don't change. It's got to be that. It's D or E, depending on which way they slice it. D. Yeah, I mean, they slice it because it's at the 20-minute mark. Yeah. I mean, like, that's a really shitty, really shitty way of asking that question. Because they make you pick. I'm gonna pick D. But, like, that's a really garbage way of asking that question. I hate how they ask that. Because, like, and it's not even, like, I guess I could have gotten it right if I had thought about it some more. Because, like, it could occur at 18 minutes. And then but, like, it doesn't get tested until 20. So it shows up as that. But, like, I really wish they didn't ask that question like that. I don't think that on the SAT they would. I know I did terrible. Don't even flame me. It doesn't even give me... Oh, there it is. You're right. I missed 10. Okay. Oh, yeah, I didn't attempt that. I know how to do it, though. Let me see if there's an easier one. Just like, I mean, a shorter one. And I'll do that, and then I'll call it a day. Part 1. How many questions? 24. I'll do halfway. The most active, most chemically active, A, fluorine. Smallest, A, fluorine. The lowest first ionization potential. It's the one that's furthest, it's acetane. It shows some visible metallic properties at room temperature. It's bromine, probably. It's bromine or chlorine. I have no idea how I would know that. It contains up to 10 electrons. D. I'm pretty sure I've done this test before, actually. Contains one pair of electrons in the ground state. Configuration at the lithium atom. It's 1s. Proposes basic postulates concerning elements and atoms. Dalton's theory proposes a relationship between Gay-Lussac's temperature volume, the one that has temperature and volume. That's Avogadro's. It's that. The organic structure that includes a functional group of aldehyde. Yeah, I'm not gonna know these. There's no way that I could. I don't know. Functional group of aldehyde. I know what aldehyde is. It's that, I guess. But I don't. That's freaking wild, brother. Because these are the same, right? What's the difference between C and D? But, alright. Yeah, I don't think there's any way that I could, I can't even find the thing after. Yeah, I just don't know organic chemistry, so it's not even that big part of, like, a big part of the test. Like, we didn't even see it, like, all day, so not we, but, like, It wasn't even like on any of the tests. Any part of that test really. It may have been on the, because it was like the first part that I didn't do, but like it may have been on there, but like wasn't even on there. I'm just gonna say fuck it and go with that, because I don't know. I don't know how else I could. Of an acid. It's it's something with like ROR. I don't know what this star means. Not necessarily the same. Okay. Alright. It's probably that. Organic structure designation that includes the functional. Okay, you really gonna troll me like that? Crack it, SAT. Identifying functional groups. Oh, I'm gonna watch this video. How long is it? Please don't be over 10 minutes.
Let's practice identifying functional groups in different compounds. So this molecule on the left is found in perfumes. And let's look for some of the functional groups that we've talked about in the previous videos. Well, here is a carbon-carbon double bond. And we know that a carbon-carbon double bond is an alkene. So here is an alkene functional group. Here's another alkene, right? Here's another carbon-carbon double bond. What is this functional group? We have an OH, and then we have the rest of the molecule. So we have ROH. ROH is an alcohol. So there's also an alcohol present in this compound. Next, let's look at aspirin. So what functional groups can we find in aspirin? Well, here is an aromatic ring, right? So this is an arene. So there's an arene functional group present in aspirin. What about this one up here? We have an OH, and the oxygen is directly bonded to a carbonyl. So let's go ahead and write that out. We have an OH, where the oxygen is directly bonded to a carbon, double bonded to an oxygen, and then we have the rest of the molecule. So hopefully you recognize this as being a carboxylic acid. So let me go ahead and write that out here. Man. So this is a carboxylic acid. All right, our next functional group, we have an oxygen, and that oxygen is directly bonded to a carbonyl, right? So here's a carbon double bonded to an oxygen. So let's write this out. We have an oxygen directly bonded to a carbonyl, and then for this oxygen, we'd have the rest of the molecule, so that's all of this stuff over here. And then on the other side of the carbonyl, we have another R group. So I'll go ahead and write that in. So that is an ester. R-O-C double bond O-R is an ester. So there's an ester functional group present in the aspirin molecule.
That's fucking wild.
Let's look at some of the common mistakes that students make. One of them is students will say a carboxylic acid is an alcohol. So let me write out here carboxylic acid so we can talk about that.
It's
so
obvious.
Sometimes the students will look at that and say, oh, well, I see an OH, and then I see the rest of the molecule, so isn't that an alcohol? But since this oxygen is right next to this carbonyl, this is a carboxylic acid. So this is an example of a carboxylic acid. If we moved the OH further away from the carbonyl, let's go ahead and draw one out like that. So here is our carbonyl, and now the OH is moved further away. Now we do have an alcohol. Now we have an OH and then the rest of the molecule. So this would be, let me go ahead and use a different color here. So now we are talking about an alcohol. So this is an alcohol.
I see.
And what would this one be? We have a carbonyl, and then we have an R group on one side and R group on the other side.
That is an ester.
That is a ketone. Let me draw this out. So when you have a carbonyl and an R group on one side and an R group on the other side, they could be the same R group, they could be a different R group. Sometimes you'll see like R prime drawn for that. So this is a ketone. So now we have a ketone and an alcohol. So two functional groups present in the same compound. So hopefully you can see the difference between this compound and this compound. This one is a carboxylic acid, and this one is a ketone and an alcohol.
I got this.
All right, another common mistake that I've seen a lot is on this functional group right here on aspirin. Students will look at this oxygen here and say, okay, I have an oxygen, and then I have an R group on one side, and I have an R group on the other side. So an R group on one side of the oxygen, an R group on the other side of the oxygen. Isn't that an ether? Well, this
No.
is
Come on, bro.
ROR would represent an ether.
Okay.
However, we have this carbonyl here. So this
Exactly.
carbonyl right next to this oxygen is what makes this an ester. How could we turn that into an ether? Let me go ahead and redraw this molecule here. So I'll first put in our ring. So I drew the double bonds a little bit differently from how I drew it up here, but it doesn't really matter. And then I'll put in our carboxylic acid up here. And now when I draw in this oxygen, I'm going to take out the carbonyl. Right, so now the carbonyl is gone, and now we do have an ether. So this actually is an ether now. We have an oxygen, we have an R group on one side, and we have the rest of the molecule over here on the other side. So now this is an ether. So hopefully you see the difference there. Look for the carbonyl right next to the oxygen. That makes it an ester.
Yo, I'm gonna look at these comments. I
right.
guarantee the comments are like, bro. Pretty much.
All right, some more common mistakes that students make is they mix up these two functional groups. So let's look at the functional groups in these two molecules here. We start with benzaldehyde, and the name is a dead giveaway as to the functional group. We're talking about an aldehyde here.
Guys.
So first we have our aromatic ring, our arene, and then we have an aldehyde. We have a carbonyl, and we have a hydrogen that's directly bonded to the carbonyl carbon. So we have an
aldehyde is hydrogen bonded to the carbon. So like, it's gotta be like something like. Okay, go back to the video.
R group, and then we have a carbonyl, and then we have a hydrogen directly bonded to our carbonyl carbon.
Back.
That is an
but why
aldehyde.
Is it OH?
If we took off that hydrogen and we put a CH3 instead, that would be the compound on the right. So now we have a CH3 directly bonded to this carbonyl carbon.
Let's see. Cause like, I'm like chilling out here, bro. But like, man, that's kind of difficult sometimes.
So now we have an R group.
What is aldehyde? Cause like it says H. Like, what is this? Aldehyde. Oh, whoa! It still says H though. Like, homie, I don't see no H. I see OH. I don't see no H though. Like, what? Like, homie. I'm gonna go with that. If it's this, then like, it's a freaking bug because I don't see no OH. That's ridiculous. Homie, that is stupid. Okay. Acid, ester. Yeah, we got the ester low key though, but like, it was like something back here. Ester was this. It was carbon bonded to the double bonded to the. It was like this, right? Or no, it was like this. It was like that. It was this thing. We had an oxygen and a double bonded oxygen. So that's like we're chilling with that. I need to check what the acid is. I'm pretty sure that
on
like,
one side a carbon
acid functional group. It's got like, it's like that, right? Yeah, it's that. Wait, hold up. It's that. Once again, if it's COD, it's like the same answer. Ether. And ether was just an ester, but without the O. So it's like something, bro. It's like that, I guess. I don't know. I have no idea what I'm doing.
Carbonyl, and then another R group. So we have R,
ether.
C double bond O, R, and
ROR. Okay, it's that. So I guess this is that. Huh. It's probably gonna be because like this is literally the same, the absolute same. So yeah. Um, okay, sure. To designate a linear nonpolar molecule that contains polar bonds. Linear nonpolar. That don't have no polar bonds, homie. Does that have polar bonds? Huh. Guess I never thought. But no, it doesn't. No way. No way, Jose. No way. No way that has polar bonds. NaCl? Nah, bro. You can't be having that. That's not. That's not. Wait. NaCl is not. NaCl is not polar. Is polar normally, and it's not. It's linear, but it's polar. Um. H2SO4. I'm sure it's 2N2O. I'm sure it's this. Cause yeah. I just think it's that. I think it's that. The expression that can be used to designate 2 moles of an atom. Okay, well, man, I remember this question and it was freaking stupid. I think that I picked H2 when it was NaCl. Did I? I may have. And maybe H2. It's either A or D. Oh wait. It's that. Because I just remember that this formula or that this was stupid. Um, wait. Hold up, bro. That designate a maximum 3 moles of ions. I'm like so out of it right now with this. Um, that's that. That's pretty obvious. Um, 2 moles of atoms. There. 3 moles of atoms. There. Maximum of 3 moles of ions. There. 6 moles of atoms. There. Um, or isotopes. That. Wait, hold up. Is it that? It's gotta be that, right? These aren't isotopes. Hold up, bro. Um, I need to figure out what an allotrope is. I've literally looked up that before. Allotropes. What is an allotrope? It's in my history. Whew, it's not good. Different forms of the same element. Okay. Those are allotropes. I mean, these are allotropes. I'm pretty sure. Those are these or something like that. Pretty sure that those have both ionic bonds and covalent bonds. I think. Obviously these don't. Those two don't. Carbon, those are all just yeah. Yeah, right? Something like that. I don't know. Our isotopes 16O. That's gotta be right, cause like O. The only reason I don't pick that is that like O is already 16. I don't really know what O2 and O3 mean. That just means that there's like more of them. I'm gonna submit. Fuck it. Wrong. It was E. Different molecular forms of. Oh, there's like ozone and stuff. Yeah, I see. I could have picked this one. I did pick it. I picked A, right? Yeah, I put A. Okay, that's stupid. Um, I put B. What did I put? I put A, right? Or I put C. Yeah, I put C. Where oxygens are 180 apart, and although the bonding is polar to carbon, counteract each other to constitute a nonpolar molecule. So oxygen, Oxygen. I feel you. I put C. Okay, so that's a bug. Uh, yeah, those are literally the same. So, yeah. It was A when it was C. Oh, did I put A? That's an alcohol. Yeah, I mean that's a stupid question because these are both there's no way. Like, what do you mean? Oh, wait. What did I put? I put A? Did I just do that wrong? Oh, okay. Well, this is that was a wash. Because like I got so many of those like wrong. Um, Simply because like I'm tired, not because I like act like I'm pretty sure I like looked at them right. I just like didn't click for some reason. I don't know. I'm stupid. Uh, I'll be like back on later probably later tonight.